Alright, so this is going to be a video on isotopes. This video will be answering the questions, what are isotopes and how is atomic mass calculated? Isotopes are variants of atoms that have the same number of protons but different number of neutrons. This means that the atoms have the same identity but a different mass. So the prefix iso means the same. The suffix tope means place. So roughly translated, isotopes just basically means same place. This same place is based on the fact that isotopes would be in the same place on the periodic table because they have the same atomic number. The periodic table is arranged by atomic number, and since that doesn't change, they would be in the same place. A good analogy of this is when you go to Chipotle and you order a burrito. Most of the burritos are normal size, while some are bigger than normal and some are smaller than normal. The burritos are still burritos, they just have a different mass. Atoms do the same thing, only instead of less or extra ingredients like the burrito, some atoms have different amounts of neutrons. Here are some examples of hydrogen isotopes. If you notice, each isotope has one proton and one electron. The number of protons, if you remember, represents the atomic number. Being that the atomic number is 1, all of the isotopes must be hydrogen, since hydrogen is the element that has an atomic number of 1. Remember, the atomic number gives the isotope its identity. The only difference between the isotopes is that one has no neutrons, another has 1 neutron, and another has 2 neutrons. You might be thinking, why are there no isotopes that have 3 neutrons, or 4 neutrons, or 5, or 100 neutrons? We're going to talk more about that later. Because each of these isotopes has a different number of neutrons, they all have a different mass number. The mass number is based on the number of protons and the number of neutrons. This is based on the fact that protons and neutrons are the only subatomic particles that have substantial mass. To find mass numbers, all you have to do is add up the number of protons and the number of neutrons. Mass numbers are used in the naming of isotopes. There are 3 different ways to write isotope names. The first way that we're going to talk about for writing isotope names involves writing the element symbol, and then in the upper left corner, you're going to want to write the mass number, and then in the lower left corner, you're going to want to write the atomic number. For example, the isotopes of hydrogen would be labeled as follows. The other 2 ways of writing isotope names involves writing the name or symbol of the element followed by a hyphen followed by the mass number. Notice all the isotope names start with hydrogen or H followed by a hyphen and then followed by the mass number. All 3 ways of writing isotope names are equivalent. Let's take a quick look at the periodic table. If you notice, each box has an element in it, and each element has an atomic number at the top and the atomic mass on the bottom. The atomic mass is not the same as the mass number. Atomic mass is the average of the masses of each isotope in the sample. It's important that you know that the atomic mass is just an average. Let's look at an example. If you collected a random sample of hydrogen atoms, you would have almost 100% of hydrogen 1, 0.0115% of hydrogen 2, and hydrogen 3 would be in such a small amount, we're just going to ignore it for this example. To find the average atomic mass, we would need to know the masses of each isotope as well as the percent abundances for each of those corresponding isotopes. Each isotope mass is multiplied by its corresponding percent abundance. These values are then added together. Note, if you have more than 2 isotopes, then you're going to need to add the product of those masses and percent abundances as well. That is why there's an ellipsis at the end of the equation. For this example, there's only going to be 2 isotopes that we're going to be using, so we're only going to need to use that equation out to 2 isotopes. Let's find the atomic mass of our hydrogen isotopes. First, using the equation, we would multiply each isotope mass by their corresponding percent abundance. Next, we would add those values up to get 1.00794, which represents our atomic mass for hydrogen. Notice that this value matches perfectly with what the periodic table says as well. This should always happen when calculating the atomic mass. So that's isotopes. If you have any questions about anything in this video, let me know.